Hi, everybody, and thanks for tuning in to this free response problem that this year that you finished at home last night and you're turning in for a grade. So this is what it looked like for you guys. Let me just read this paragraph again to redefine what we're talking about. It says the function f is defined on the closed interval -5 to 4. The graph of f consists of 3 line segments and is shown in this figure here. Let g be the function defined by g of x equals the definite integral from -3 to x of f of t dt. And you worked your way through these 4 problems. Now, because I have no space here, I'm going to kind of pull this away. And what I did here is I just left the graph here, and I'm going to start in with part A here. So part A asks you to find g of 3. So g of 3 is what we're looking for. Okay, well, right above this, let me just click and drag this over. I was given that g of x was equal to the definite integral from -3 to x of f of t dt. So following suit, if I want to find g of 3, well, my x just became a 3. That means on the right side of the equation, I have to replace this x with a 3. So it will be, so g of 3 will equal the definite integral from -3 to +3 of f of t dt. And now this is where normally I would run a fundamental theorem of calculus, but I don't have an equation per se of f of t. F of t was given to me right here as a graph. So I'm going to find this definite integral, but I'm going to go at it from a graphical standpoint. So I know that the definite integral from -3 to +3 represents the signed area trapped under the graph and between the x-axis and the graph f from -3 to 3. So since -3 sits right here, and +3 sits right here, I've got to color in or shade in all the trapped area. So I've got a triangle here from -3 to +2, and this is all positive because it's above the x-axis. This is all positive area. And then from 2 to 3, it looks like I'm coming under. And if I trap that and shade, that is going to be another triangle just with a negative sign on its area. Okay, so the first thing I'm going to do now that I have that shaded in is I'm going to break this down and say that g of 3 can now be written as the definite integral from -3 to +2 of f of t dt, and then added to the definite integral from 2 to 3 of f of t dt. And I'm just doing that because these are 2 different triangles that I'm representing here. This is the one above the x-axis, this is the one below the x-axis. So now geometrically, I'm going to find these signed areas and add them together. So now I'm going to write g of 3 equals. Okay, so from -3 to 2, this triangle is just going to be given geometrically by 1/2 times the base times the height. So the base looks to be 1, 2, 3, 4, 5 units long, and the height 1, 2, 3, 4 units high. And to that, I'm going to add this triangle. Well, this triangle's signed area, so it's going to be another 1/2 base times height. Now the base is just 1 unit long, and the height, it looks, if I eyeball it, it looks to be -2, but I don't want to assume that. Remember, no assumptions in these open response problems. So instead of making the assumption that this height is -2, I'm going to go ahead and write the equation of this line segment, connecting 0, 4 to 4, -4. And I can do this really quickly because my slope looks like I'm coming down 4 units and right 2, and then down another 4 units and right 2. So I'm pretty confident that my slope is -2. So I have y equals -2x. And my b value is given to me because I can see that the y-intercept of this line segment is 4. So I'm going to go ahead and say that this line segment right here has this equation to go with it. So now if I want the y value when x is 3, I can simply substitute 3 in for x. And that will give me a y value of -2. So it was what I suspected it was, but I want to double check that just to be sure. So when x is 3, my y value or my height of this triangle is -2. Okay, so final answer for g of 3, and to finish off part A, is g of 3 is equal to half of 10, half of 20, which is 10, plus half of -2, that's going to be -1. And so g of 3 is 9. Final answer. Now, when I look at my AP scoring guide, for getting this answer correct, they are going to award you 1 point. So what I want you to do right now is if you got g of 3 equals 9, add a point to your score, +1. Okay? And in my scoring guide, you can see that. This is my scoring guide, and you can see they did a little less work than me here. They said that g of 3 was the definite integral from -3 to 3, and they did some geometric calculations. I got 9. They're giving you 1 point for that answer, 9. So in that one, they're really not checking much of your work, just awarding points for that final answer. Okay, let's go on to part B. I'm kind of out of room here, aren't I? Let me go grab some more paper. Turn behind me here. So we've got part A. Now, let's get on to part B. I'm going to kind of cover up part A and move on to part B. Okay, so what does part B say? Part B says, on what open intervals contained between -5 and 4, open interval -5 to 4, is the graph of G both increasing and concave down? Give a reason for your answer. So this is really playing off of Unit 3, applications of the derivative. So we got to think back to Unit 3 when we talked about increasing versus decreasing behavior and concave up versus concave down. So I want to kind of start from a point that goes like this. I want to start back with g of x. Let's go back to that given. G of x is the definite integral from -3 to x of f of t dt. Now, we want to know when g is increasing. Well, if I remember correctly, increasing behavior is defined by g's first derivative. So we know that g prime of x will be equal to the derivative of this definite integral. And if I use part 2 of the fundamental theorem of calculus, I know that the shortcut to find a derivative of a definite integral asks me to take the upper bound x and put it here. So g prime of x is equal to f of x. So if I want to know where g is increasing, I want to know where g prime, which is f, is positive. So g prime of x, which is also equal to f of x, needs to be positive in order for g to be increasing. So what I need to do is come over here to my graph, and I need to highlight where is f, this is the graph of f, where is f positive? Well, if this is the graph of f, then the values of f are positive when we're above the x-axis. So I would say f is positive here, here, and here. Everything else that's under would be f negative. So that's a good start. Now that takes care of where g would be increasing. Now, secondly, we need to be concave down. Well, concavity is determined by the second derivative. So the second derivative of g is the first derivative of f, and in order to be concave down, f prime of x needs to be negative. And if you think about it, f prime will be found by looking at the slopes of the tangent lines on the graph of f. So we're looking for negative slopes from this graph. Now, I'm already sort of stuck on the pink. So in the pink areas that are already highlighted, my slopes are negative here and here. So the highlighting that takes care of both of these, where g is increasing and concave down, would be from -5 to -3, union 0 to 2. So let me write this as a final answer now. So this is how I'm going to write my final answer. I'm going to say the graph of g is both increasing and concave down. See how that's looking. The graph of g is both increasing and concave down on the intervals. Here we go. -5 less than x less than -3 union 0 less than x less than 2. And I'm going to say, since I'm just looking at my work here, so I say this perfectly, since f of x is positive, and you can see I'm kind of running out of room here, since f of x is positive, that's this part right here, and now I'm running out of room here, so I'll come over here, and f prime of x, that's this one, is negative on these intervals. And that would be a great answer for part B. Now let me tell you what points were awarded for this one. This entire answer on a free response, they had worth 2 points. You got 1 point for correctly identifying these two intervals. So if you have x between -5 and -3, and also between 0 and 2, you give yourself a point. Give yourself a point. And the other point they awarded was for the explanation, the justification. So if you said that f of x was positive and that f prime of x was negative, this part right here, something to that effect, you give yourself another point. So 2 points. Intervals, reason. Okay, very nice. So let's pull that graph back here. I'm not sure if we need it anymore though. Do we actually? I don't even think, oh yeah, we do need it. We do need it. So let me grab another sheet of paper and on we go to part C. Okay, so part C, let's put it right here where we can see it. Part C says, the function h is defined by h of x equals, looking here, h of x equals g of x divided by 5x, and they want us to find h prime of 3. Well, we can't find h prime of 3 until we find h prime of x. So in order to find the derivative of h, we're going to have to utilize the quotient rule because we have a quotient. So here we go. The quotient rule says you take the denominator, so 5x, and you multiply by the derivative of the numerator. Well, the derivative of g of x is g prime of x. And then you subtract the numerator, g of x, times the derivative of the denominator, which is 5. And then you take all of that and divide it by the denominator quantity squared. Okay, so then I have my derivative. Now, believe it or not, if you got that part right by quotient rule, they are actually giving you 2 solid points for that on the AP exam. So give yourself a +2 if you have that much correct. Now, the third point comes in when you plug your 3 in. So here we go, calculating h prime of 3. So we've got g of 3. No, we don't. Wrong, Callahan. I was looking up here at this, not my derivative. Let's start that again. So h prime of 3, here we go. 5 times 3, 5 times 3, times g prime of 3 minus g of 3 times 5 all over 5 times 3 quantity squared. Okay, moving on, I have h prime of 3 equals, okay, 5 times 3, that's going to give me 15, so 15. Now, g prime of 3. Well, I think we already established that, didn't we establish that, let me come in here, didn't we establish that g prime of x was equal to f of x from part 2 of the fundamental theorem earlier? So g prime of 3 is just f of 3. And if I go to my f graph here, we already established that f of 3 was -2. So that's what I'm going to put for g prime of 3. And then minus, and now I've got to take g of 3. I got g of 3 in part A. Look back to your answer from part A. It was 9, wasn't it? So g of 3 is 9 times 5. And then this is all over 5 times 3 is 15. 15 to the second power is 225. Okay, so finishing this up, I have 15 times -2 is -30 minus 45 all over 225, which would then equal -75 over 225. And if you reduce that fully, you actually get -1/3. Final answer. And they're going to award you a point for getting -1/3. So that's part C. Pretty straightforward. Straightforward in the quotient rule, but then a little bit more abstract when you have to get g prime of 3 and g of 3. You got to come back to some of the givens. Okay, and last but not least, let's see if I can fit it right here. Letter D. Letter D says, the function p is defined by p of x equals f of x squared minus x. They want me to find the slope of the tangent line to p when x is -1. Well, in order to find slope, I need p prime. So let's get that straight right off the bat. I need p prime. This is going to give me my slope of the tangent line anywhere. After I get p prime, I'll substitute -1 in for x. So this is a little tricky over here because I have f of x squared minus x, and I don't even have an equation for f. I have a graph for f. So I can't even deal with that really wholeheartedly. So I need you to think back to when we were learning derivatives. This is actually the outside-inside rule. Now let me review that with you really quickly. We use the outside-inside rule a lot with trigonometry. So let me just do a side note. Let me kind of change colors here. Let me get in the purple here. So this is just a side note. Say I gave you like y equals the sine of 5x, right? And I wanted you to find y prime. So the outside-inside rule said you took the derivative of sine, which was cosine. So watch what I'm going to do over here. So since it's f of, and this was sine of, and the derivative of sine is cosine, well, the derivative of f is f prime. So sine to cosine, f to f prime. And then didn't we just bring down the 5x? We said that the derivative of sine of 5x was cosine of 5x, so let's just bring down x squared minus x. And then last but not least, we multiplied by the derivative of this piece, which was just 5. So over here, we're going to multiply by the derivative of this, which is 2x minus 1. So the outside-inside rule takes the sine of 5x to the cosine of 5x times 5. The outside-inside rule takes f of x squared minus x to f prime of x squared minus x times 2x minus 1. And the rest is history. Watch how easy this is. Now we want the slope of the tangent line when x is negative 1. So let's just replace all these x's with negative 1. So that will give me f prime of negative 1 squared minus negative 1. Keep that straight. Times 2 times negative 1 minus 1. Okay? This is going to equal f prime of, let's do the math in this parentheses. Negative 1 squared is positive 1, plus 1 is 2, times 2 times negative 1 is negative 2 minus 1 is negative 3. And we know that f prime of 2, well, this is the graph of f. The slope of f at x equals 2 would be the slope of this line segment, which we already know right here from earlier is negative 2. So f prime when x is 2 is negative 2 times negative 3, positive 6. Final answer. Where are the points awarded? Well, they're giving you 2 points for this line right here. 2 flat out points for the correct outside-inside rule here, and 1 point for the 6. So let's see if our points add up to 9. Let's see. So part D was 3 points. Part C was 3 points. So there's 6. And then part B, 7, 8. And then part A, 9. So give yourself your score on this problem out of 9. And really, thanks for watching. I just wanted to go through that so you could kind of self-score yourself on this one, which can be pretty interesting to do. Okay, thanks for watching.